Hello, ladies and gentlemen. We're going to start off with A1. That's like an appendix or something in the beginning, where this is just a skill that you learn in algebra that we need to now be able to do pretty well for simplifying things. So this is simplifying radicals and rational exponents. So what we're going to do is, first, sometimes you see these sorts of book definitions and it's like, what does that mean? Let me put some numbers in there and kind of refresh your memory here. So if I say something like the square root of 9, you might also write that as 9 to the 1/2 power. Oops, let's try that again. 1/2 power. Square roots as exponents are fractions. The denominator tells you the root. So we don't normally write the second root of 9. It's implied to be a 2. But if you want to find different roots, that's how you write that. So for example, the third root of 27 is 3 because 3 to the third power is 27. So the denominator, if you ever see a rational exponent, that means there's a fraction. If you ever see a fraction in your exponent, the denominator tells you the root. And the numerator tells you a power. Now this can be kind of tricky. So if I say something like let's say, how about 27 to the 3/2, or let's do 2/3, okay? So we just found the third root of 27. So this is like saying the third root of 27, because the denominator is your root, but then you're going to square that. So you can simplify this a couple ways. You could say the third root of 27 is 3, and 3 squared is 9. Or you could also do it like this, the third root of underneath the root 27 squared. Now, if you know 27 squared off the top of your head, great, but I don't, so I'm going to do it like this basically. And that's sort of a thing that messes with people, is you could do it in a different order and get the same answer. It's just you might not know 27 squared on the top of your head. So the main thing you need to take from this is the denominator tells you the root. So like that was a 3, I guess, but the denominator tells you the root. So anytime you see this would be 27 to the 1/3, get out of here. 27 to the 1/3 will be written as the third root of 27. And then if you put a numerator in there, that's going to square the answer, or you can square what's called the radicand, the part underneath the root. So let's do some problems and see if we can kind of make sense of this. So this says rewrite the exponent as a radical expression. So you could write this as, if the denominator is 2, that means I'm taking the square root of x, and you could write it like this, to the 5th power, or you could also write it like this, the square root of x with the 5 underneath the root. Both of these are correct, and depending on what you're trying to do, one of them might be more useful than the other. You might take the square root first and then take it to the 5th power, or you might take it to the 5th power and then deal with the square root. It just depends on what you're trying to do. So let's do another one. This one would be the 6th root, because 6 is the denominator, of, and you got to be careful, the quantity 10x, so that's underneath. You could write it the whole thing to the 5th power like that, or the 6th root of, and then in parentheses 10x to the 5th. Now that really matters that you have that quantity, because it's not just 10 that's going to the 5th power, and it's not just x that's going to the 5th power. It's 10x. 10x is going to the 5th power, so the whole thing. So to simplify this, because you could simplify that, you could say the 6th root of 10x to the 5th power would be 10x, I could write it out just to remind you, 10x times 10x times 10x times 10x times 10x, which is like saying 10 to the 5th, x to the 5th. Well, 10 to the 5th is a 1 with 5 zeros, and then x to the 5th is just x to the 5th. So this could be written as the 6th root of 100,000 x to the 5th. And that's probably the best answer because it does simplify that 10x. So the 6th root of 100,000 x to the 5th would be your best answer. Let's do a couple more. M to the 7/5. So the 5 tells you we're taking the 5th root of, and you could write it like this, m to the 7th, or you could do the 5th root of m to the 7th. Kind of messed up there. The 5th root of m to the 7th underneath. Both of these are correct, and you can use either one depending on what you're doing. This would be the cube root of 3n quantity squared, or the cube root of 3n quantity squared. That can simplify. Remember, this is 3n times 3n, so this would be the cube root of 3 times 3 is 9, and n times n is n squared. The cube root of 9n squared. The 5th root of 2x all to the 6th power, or the 5th root of the quantity 2x to the 6th power. So you can simplify that. That'd be 2 to the 6th x to the 6th underneath. And 2 to the 6th, 2, 4, 8, 16, 32, 64 is 64. So 64x to the 6th, that's the 5th root of 64x to the 6th. Okay? One more. 4k to the 1/3, that's the cube root of 4k. And you can say to the 1st power, but it seems kind of silly because it already is implied to be the 1st power. So that's really the only way I'm going to write that, the 3rd root of the quantity 4k. Okay, so that's going from an exponent to a radical. What if we go the other way, from a radical to an exponent? So this would be, remember, the denominator is the root. So we would say 3x to the 1/4 power. It's the quantity 3x all going to the root of the power of 1/4. That's the 4th root. This would be 5 to the 1/3 because it's the 3rd root of 5. This would be the square root, so that would be 10xy to the 1/2. So since these are all, there's not really a lot of simplifying I'm doing here, I'm just rewriting them. 10xy to the 1/2 power. But the parentheses are important. If you don't put the parentheses, that's wrong. If I write this is not correct because what this is saying is 10x times the square root of y. That exponent is only being applied to the y. You need to make sure you understand the difference. It's the quantity that is all underneath the root. So all of that needs to be underneath. Now let's practice simplifying radicals. So sometimes you can do these in your head and you can just figure out the roots, but I'm going to show you a strategy that works for any type of root and any type of, really any type of simplified problem here. The first thing I'm going to do is to get a prime factorization of 64. So if it helps you, make a factor tree like 32 and 2, 16 and 2, 8 and 2, 4 and 2, oh no, we're out of space, and then 2 and 2. So 64, we just did this, was 1, 2, 3, 4, 5, that's 2 to the 6th power. So 2 to the 6th. So what I'm going to do is, if I factor 64, I'm going to put 2 times 2 times 2 times 2 times 2 times 2. That's 6 2's, and k squared is k times k. So that's all underneath the root. I'm trying to draw that better, like this. The 3's on the outside. If it asks you to find the square root, what I'm going to do is look for pairs. And everywhere I see a pair, I'm going to kind of circle that and say, that's important. So when I see a pair of 2's, I'm going to circle that. And another pair of 2's, and another pair of 2's, and a pair of k's. And I'm going to think about what that means. 2 times 2 is 4. The square root of 4 is 2. So what we're finding is pairs. If it's a square root, for every 2 of these underneath, one of them is going to make it out, because the square root of 2 times 2 is 2. So we have a 3 on the outside. One of these 2's is going to come out. Another 2 is going to come out. Another 2 is going to come out. And a k is going to come out. Well, what's left underneath the root? Nothing. It all comes out. So we have 3, 2, 2, 2 on the outside. If you do 3 times 2 times 2 times 2, you get 24. And then you just have k, so 24k. This simplifies to 24 times k. You could have probably done that in your head, because this one is a perfect square. You're like, oh, the square root of 64, that's 8. The square root of k squared is k. So 3 times 8k is 24k. You get the same answer. There's lots of ways to get there. I'm just giving you a strategy that works every time. So let's try another square root problem. 5 times. Let's see. 175 is 25 times 7. So that would be 5 times 5 times 7. If you can do it in your head, great. If not, make a factor tree. That's okay. Now we're looking for pairs underneath. Found one. So 1 5 is going to make it out, but there's already another 5 out here, so that 5 is going to join him. And then underneath, a 7, he doesn't have any friends, so he's not coming out. And W doesn't have any friends, so he's not coming out, so it's 7W stuck in the root. On the outside, though, I can simplify that. That's 25 radical 7W. There you go. Next one's kind of tricky. It's a negative, so sometimes you're like, negatives? You can't do negatives under roots. You can't do even negatives under roots, but you can do odd roots. For example, the cube root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2, you'll have an odd amount of negatives. 2 times 2 is 8, and the negative these will cancel out, but 1 will survive. So be careful here. When you have an odd root, you can have a negative radicand, the part underneath the radical. So what I'm going to do is be like, all right, I got negative 2 times the fifth root of 96 is, let's see, 2 times 48, which is 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. Again, make a factor tree if you want. Now the fact that it's negative, I'll just kind of put like a little negative 1 in there and just be like, yeah, I'm going to address that in a second. So if it's a negative, what's going to happen is any root of a negative number is going to be that negative. So if it's negative 1, we're just going to bring the negative out. So now we have a negative 2 times a negative 1, which is going to be positive 2 on the outside. So this negative, you kind of just ignore and be like, well, it's a negative, it's an odd root, so it's just going to come out. We have positive 2 on the outside. What else do I have here? A 2. Oh, wait, no. This is a fifth root. So I'm not looking for pairs of 2. This is a fifth root, so I'm looking for pairs of 5. 1, 2, 3, 4, 5. It doesn't take 2 2s to get out. It takes 5 2s to get out. So you need to have a pair of 5, or a set of 5 2s to get one of them out. So we already had a 2 out, and the negative made it positive. Now, all 5 of these can make one fifth root, so another 2 will come out now. And underneath, I'm still taking the fifth root of this 3 is trapped. He doesn't have 4 other buddies. So now on the outside, I have 2 times 2, which is 4 times the fifth root of that 3 is stuck. So 4 times the fifth root of 3 is your answer. Pay attention to what root it is. If it's a fifth root, you need sets of 5. Square roots, you need sets of 2. So cube root, I need to find sets of 3. First thing I'm going to do, prime factorization. So the cube root of 135. Let's see, what's 135? I know it's a multiple of 5, so I'll just do 135 divided by 5. That's 27, right? So 5 times 27. 27 is 3 times 9, which is 3 times 3. And then I have r times r. So make sure you can get the factorization, 5 times 3 times 3 times 3 to get 135. And then you can look for sets. I'm looking for sets of 3. Found one. Let me set this to the back. There you go. So for every set of 3s, one of them will come out. So I have 6 times 3 on the outside, and I have the cube root of what's trapped in there? 5, and these two r's, so r squared. 6 times 3 is 18, so this is 18 times the cube root of 5r squared. Okay. Let's do another one. We have a negative 6 on the outside, so we need to do a prime factorization on the inside. The cube root of 189. So let's see, 189, that's divisible by 3. I know that because the digits add up to, this is a good trick. If you add up the digits of a number, you get 18. And since 18 is divisible by 3, 189 is. That works for 3 and 9. It's kind of a cool trick. So I'll say, let's see, that's 3 times 63. 63 is 9 times 7, so 7 times... Oh, I'm going to write that in a different order. 9 times 7 is 3 times 3 times 7. So check that. Make sure if you do 3 times 3 times 3 times 7, you get 189. I do. And then I'm going to write u to the 5th, v to the 5th, and we'll take care of that in a second. Okay, because I'm going to try and do this in my head. So cube root means I'm looking for sets of 3. Found one. That's going to come to the outside. So there's already a negative 6. Negative 6 times 3 is negative 18. And now, I'm not going to write all these out. I'm going to see if we can do this in our head. If there are 5 of them, there are 5 u's underneath the root, and I'm looking for sets of 3, I will be able to bring one set of 3 out. So I will have a u on the outside, and I will have a v on the outside. I still have a cube root. If you bring 3 of them out, that's a set of 3, there's still 2 left underneath. So the 7 is trapped. And then 2 of these u's and 2 of these v's are also trapped. So it should be negative 18 u times v times the third root of 7u squared v squared. One more like this. We'll do negative 8 on the outside, and now we're doing the fourth root of 243. I think that's 3 to the 5th. Oh, no, 3 to the 5th, right? Yeah. Okay, so 3 to the 5th. So this is 1, 2, 3, 4, 5 3's. A, b squared. Now remember, this is a fourth root, so we're looking for sets of 4. We got one. So for every 4 underneath, 1 makes it out. There's already a negative 8 out there, so that's going to be negative 24. This a doesn't have, there's not 4 of them. There's not 4 b's either, so this is all trapped on the inside. I have the fourth root of 3a 2ab squared. Now when you write these, it is easy to make them hard to understand, like what do you mean? Make sure you can tell that's the root, so that's a little better. So negative 24 times the fourth root of the quantity 3ab squared. Alright, so that is simplifying radicals. Now let's see if we can simplify exponential expressions. Probably you might want to just treat them the same way and write them as a radical. So if I take this guy and write it as a radical, this is 1/2, so this is the square root of 25n squared. Now, you might be able to do this one in your head because 25 is a perfect square. The square root of 25 is 5. The square root of n squared is n because there's a pair of 5s and there's a pair of n's. So this is just 5n. Let's do another one. I could write this two ways. The cube root of 27x cubed to the 5th, or the cube root of 27x cubed, the quantity, to the 5th. Now, if you know 27 to the 5th power, good for you. And then if you can do the cube root of that, good for you. But I don't, and I don't really need to. What I'm going to do is kind of focus on this guy. So I'm going to figure out the cube root of 27x cubed first. Now, that's 3x, but let me show you why. 27 is 3 times 3 times 3, and x is x times x times x. So I'm going to figure out what that is and take it to the 5th power. So here's how. Look for set of 3s, everything comes out. You have 3x on the inside to the 5th power. Now you got to be careful, use your exponent rules. This is a quantity to a power. So this is 3 to the 5th and x to the 5th. And 3 to the 5th we just talked about. 3 to the 5th is 243, so this is 243 x to the 5th. Alright, what about a negative exponent? What does that mean? So negative exponent actually doesn't mean negative numbers. Negative exponent means wrong side of the fraction bar. So if you kind of assume this is all on the top of a fraction, now we're going to write it in the bottom of a fraction. So I'm going to put 1 over, and this is the square root of 81k squared, that's underneath, to the 3rd power. So the fact that it's negative just means we're going to put it in the bottom of a fraction. We'll put the 1 in the top. 1 over. 81k squared, since it's a denominator of 2, it's a square root. And since it's 3 for your power, we're going to take it all to the 3rd power. So we can do this one in our head. The square root of 81k squared is 9k, and that's going to go to the 3rd power. So if I do, what we got to do here, 9 to the 3rd. Oh, my lights just kicked off. 9 to the 3rd. 729. So this is 1 over 729k to the 3rd because you got to cube the 9 and cube the k. So 1 over 729k cubed. A few more and then we'll be done. So again, negative exponent means put it in the denominator, 1 over. Now it's the square root of 16k squared because 2 is the root. So we're taking the square root. I can do that one in my head as well. The square root of 16 is 4. The square root of k squared is k, so 1 over 4k. Now, you can do this a couple ways. Let's just leave it alone and kind of say, what's the 4th root of a to the 8th? I can write that better. A to the 8th all cubed. Let's see if we can figure this one out. Or maybe it would be better to do this. A to the 8 cubed. So which one do we like? You know what? I think I like this one. So this is a power to a power, which means we're going to multiply 8 times 3 and get 24. The reason why is if it says to cube something, you would do a to the 8th times a to the 8th times a to the 8th, which if you then wrote these all out, it would be a times a times a times a, there'd be 24 of them. It'd be a lot. So I'm not going to write them all out, just say 24. Now, yeah, I know I'm looking for sets of 4, so I'm like, let's see. How many sets of 4 are there going to be if there's 24 of them? I think it'd be 6, so this is just a to the 6th. Okay? I can do this a couple different ways, and maybe this would make things easier for you if you think about it this way. You could just simplify the root out the gate. So you could say 8 times 3, that's 24, and then it's over 4, and you just get a to the 6th that way. So it's important that you're kind of fluid here with the way you do these things. It might not always be the fastest to kind of break it down. You might be able to do it quicker a different way. But you've got to follow the same rules. One more. Before I do anything, I'm going to deal with this negative exponent. So negative exponents mean they're on the wrong side of the fraction bar. So I'm going to first leave x cubed alone and bring this up to the top. So now it's x cubed y squared, still to the 1/2 power. So that's the square root of x cubed y squared. Now, you might be able to do this in your head. I know it's going to be xy radical x. But let me show you why. X times x times x times y times y. If we're doing square roots, we're looking for pairs. So one x comes out, one y comes out, and the x is trapped. All I did was say there's one pair, and there's going to be one left over because it's odd. The 2 is even, so it's all going to come out. So xy radical x is your answer. So that's it for simplifying roots and rational exponents. At least that's our start. What you have now is on Khan Academy, you have some exercises. These are all things that we've just gone over. You should be able to do. So go ahead and get those done. And that's it for our A1 first lesson. Be sure to hit that like and subscribe button, and have a good day.